Alright, hello everyone, this is Miss Scott. Today we're going to talk about parallelograms and we're going to learn about some relationships between the sides and the angles in a parallelogram. Well, before we get into that, we should figure out a definition of a parallelogram. So, a parallelogram is defined as a quadrilateral, and remember, quadrilateral means it has four sides, with opposite sides parallel, hence the name parallelogram. So in this figure here, we need to show that the opposite sides are parallel. And if you remember from earlier this year, we do that with these arrows. So the top two sides need to be parallel, and these sides need to be parallel. Alright, so this is a parallelogram. And we're going to learn four theorems about these quadrilaterals. The first one is pretty straightforward. This tells us that if a quadrilateral is a parallelogram, then its sides, opposite sides, turns out that those are congruent. So this side is congruent to this side, and this side is congruent to this side. So let's use that to do example 1. Find the value of each variable in the parallelogram. Well, since this is a parallelogram, this side is congruent to this side, meaning x is 11, and this side is congruent to this side, meaning y is 8. So we found the value of each variable. Pretty simple. Our next example deals with angles. So theorem 8.4 tells us that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So this acute angle here is the same measure as this acute angle here. This obtuse angle is the same measure as this obtuse angle. Okay, so if we look here, we're asked to find the value of n in the parallelogram. Well, since this is a parallelogram, that means these two angles must be congruent, and we can say 4n is equal to 76. So dividing both sides by 4 will get us n by itself, and 76 divided by 4 is 19. So n is 19. Alright, the next two theorems get a little bit trickier, but they're still pretty straightforward. So theorem 8.5 again tells us that if a quadrilateral is a parallelogram, then it's consecutive, meaning one after another or next to each other. The consecutive angles are supplementary. And if you recall from earlier this year, supplementary means that they add up to 180 degrees. So let's call this parallelogram over here A, B, C, D. So any two angles that are next to each other are going to add up to 180 degrees. For example, if we would add the measure of angle A to the measure of angle B, that would be 180 degrees. And that would work with any pair. It would also work B and D would add up to 180. C and D would add up to 180. And A and C would add up to 180. So it works for any two angles that are next to each other. Let's use that on this next example. We're asked to find the measures of the three missing angles in the parallelogram. So I only know this one angle F. Well, using theorem 8.5, we can say that 136 degrees plus the angle next to it, which is angle G, is equal to 180 degrees. And I want to figure out the measure of angle G. To do that, we're going to subtract 136 from both sides. So these cancel, and we end up with the measure of angle G is equal to 180 minus 136, which is 44 degrees. Okay, so now we just have to find angles E and H. Well, from theorem 8.4, we know that the angles opposite are congruent. So across from angle F is angle H. So we know angle F is congruent to angle H. And if you remember, that's just by theorem 8.4. Okay, so if we know angle F is 136 degrees, while angle H is also 136 degrees. All right, and then it also works with angle G. Is congruent to the angle across from it, which in this case is angle E. So we know angle G is 44 degrees, so angle E is also 44 degrees. Okay, so we found the other three missing angles right here. All right, in our next example, we're going to use theorem 8.6, which is about the diagonals of a parallelogram. So if a quadrilateral is a parallelogram, then its diagonals bisect each other. All right, so remember the diagonals in a shape go from one corner to the opposite. So there's one diagonal and the other. And those cut each other in half. That, remember, is what it means to bisect, meaning that this and this are the same length, and so is this part and this part. Okay, so if you want some letters to kind of make a little more sense of that, if we call this parallelogram A, B, C, D, and then I'm going to call this point where these two cross M, it turns out that AM is the same length as MC, and BM is the same length as MD. Okay, so we're going to use that idea in our last example for today, which asks us to find the value of the variables in the parallelogram. All right, since this is a parallelogram, these diagonals bisect each other. So if we look here, that means 12 has to be the same as 3x plus 6. So we can set 3x plus 6 equal to 12 and solve for x. So first we subtract 6 from both sides. These will cancel. We end up with 3x equals 6. And then we're going to divide both sides by 3. And that is going to give us 2 for x. All right, same with that second diagonal. So 2y plus 9 has to be 27, meaning we can set 2y plus 9 equal to 27. And to get y by itself, we're going to subtract that 9 from both sides. These will cancel, and we end up with 2y equals 27 minus 9, which is 18. And lastly, dividing by 2, we'll get y by itself, and 18 divided by 2 gives us 9. So y is 9. All right, so use these 4 theorems to figure out pretty much anything you need to about parallelograms. If you guys have any questions, please ask me.